Hi, I'm Mike Fairborn, Chief Meteorologist here at WCCO TV. Go for Rocks is the 8th natural science series that we've produced here at the Weather Center. This one's about geology, the study of the Earth and its history over millions of years. Did you ever play the game Animal, Mineral, or Vegetable? Well, geology's about minerals, the building blocks of rocks and plants and animals. For those of you following along with the Go for Rocks worksheet, here's how that works. At the start of each story, I'll present the topic, then watch and listen for the main points. Make some notes. At the end of the story, you'll see a list of answers that you can write in the worksheet. The appeal of rocks is almost universal. Who hasn't picked up an interesting rock sometime or other? Watching young people on a field trip, you can see why some geologists are called rock hounds, no matter which of the 3 main types of rock they're after.
Here, look it. Here you go, guys. See, there's lots of shells in there, see that? But this will show you that it really was a sea, the kinds of animals that are in here.
Geologists of all ages love outcrops and road cuts. This one in southeastern Minnesota has fossils from an ancient ocean. The exposed rock tells the story of geology, the study of the Earth and its history over millions of years.
Where did you find it?
I found it actually right in this road cut.
Every rock has a story, often with millions of chapters. The oldest rock found in the United States is here in Minnesota. Our region has a wide variety of rocks. Most rocks are made of minerals, natural combinations of chemical elements. With more than 2,000 minerals in the Earth's crust, there are lots of different rocks. Geologists have learned that they form in 3 main ways.
Rocks are formed, first off, from molten material. The Earth at depth is molten. The molten material, when it comes toward the surface or when it moves to an area where there's less pressure, will become solid.
These rocks are called igneous, from the Latin word for fire. The second main type of rock is made from sediments, any loose material, sand or clay or gravel at the Earth's surface.
Now this sediment was sand, and what happened is after a while it got piled up so thick that the water was forced out of it, so that sediment sand became the sedimentary rock called sandstone.
Throughout southeastern Minnesota, roads or rivers cut through layers of sandstone and limestone, another sedimentary rock.
The third principal kind of rock is called metamorphic, from metamorphosis, change. Those are rocks which have formed at depth under high temperature and high pressure. They are the changed rocks.
Metamorphic rocks can form from both igneous and sedimentary rocks. But no matter what type it is, when a rockhound finds it, that's the start of a collection.
This one is in the shape of South Carolina.
Whatever the shape of the rock, geologists classify it by the minerals and processes that form it. Do you know the names of the 3 main types of rock? They're igneous, those rocks made from molten materials, sedimentary, the rocks made from sediments, and metamorphic, the changed rocks, either igneous or sedimentary rocks that are changed by heat and pressure. When most of us hear the word geology, we think of mining, and humans have mined in our region since they first gathered copper from the rock outcrops of the St. Croix River Valley thousands of years ago. Today, many rocks and minerals are mined in Minnesota. It's our 3rd biggest natural resource industry. Using wedges and sledgehammers or front-end loaders as big as a house, Minnesotans dig it. The old stone face keeps watch in Pipestone National Monument. Sioux quartzite, Minnesota's hardest rock, is exposed here, and native peoples have had quarries in it for centuries. With wedges and sledgehammers, they remove the quartzite to get at a thin layer of pipestone, 12 feet down.
Only way you can do it. Because I think if you use power tools, the stone is so fragile it'd break. So you're better off just doing it by hand.
The Europeans who came to the upper Midwest quarried rock too. From the river bluffs they cut limestone and sandstone to build buildings that still honor the stonecutter's art. Many Twin Cities buildings have fine examples of stone quarried in Minnesota. The WCCO Television building here on the Nicollet Mall has Kasota stone, a limestone quarried in Mankato. And granite, like this piece of Rockville White, is another Minnesota building stone.
Within this quarry We drill and blast to break the large chunks into pieces that we can haul over the road, which are roughly 20 tons in weight. They're hauled from here to a sawing facility where they're cut with a large diameter circle saw or a shot saw, which looks like a reciprocating hacksaw.
In the finishing plant, the slabs are polished or roughened with a flame, depending on the design. Then they're cut to the exact shape required. Every piece of stone has an order attached to it.
Granite's a very hard rock, but when the appropriate manpower and craftsmanship is applied to it, it produces some very beautiful products.
Minnesota's largest mining industry by far is iron ore. Every year since 1901, the Iron Range has produced more iron ore than any place else in the nation. Minnesota's richest iron ore deposits were used up during the 1970s. Now, millions of tons of a lower grade ore, taconite, are mined. Can you name 4 of the earliest stones and minerals mined in Minnesota? They're pipestone, still quarried with hand tools in southwestern Minnesota, limestone, Minnesota's first building stone, and granite, mined near St. Cloud and Morton, and the most important economically, iron ore. So, why are these natural resources where they are? To figure that out, we have to look through the rocks to the processes that form them, the natural forces that change the land, like fire and ice. These changes happen on a broad time scale, an instant for an earthquake or volcano, millions of years for building a mountain range. The landmass that became Minnesota, like all land masses, was built over long periods of alternating changes, mountain building and eroding. 10,000 years ago, it was glaciers, huge sheets of ice that changed Minnesota's landscape, creating the hills and the valleys that we see each day.
Tell about this landscape. I start with landscape because the thing we're most involved with every day. It's what we drive up and down. It's what we slide, you know, it's what we ski on. It's what we have in our backyard.
The shape of the land around us, hills, plains, and valleys, is the key to unlock the treasures of geology. From the top of Buck Hill, you can see miles and miles of rolling hills. But where'd they come from?
These hills now, these aren't eternal as the hills, you know, actually here. These are not eternal hills. These hills are from the most recent glaciation, from the most recent time that the glaciers came down over Minnesota, and they stopped just about here, this last set.
That was 10,000 years ago. But off and on, during the last 2 million years, glaciers covered large portions of North America. And the changes they made to the landscape are found all over Minnesota.
These lines in the pink rock here are subquartzite, and they indicate the travel of the glacier moving through here.
200 miles north, near Holly, wind and waves left sandy ridges on the edges of an ancient glacial lake. Beaches from a bygone time.
You know what this is?
Timeline. No.
That's a geologic timeline.
Geologists calculate the Earth is 4.5 billion years old. So, when natural forces like we experience every day are multiplied over thousands and millions of years, great changes are inevitable.
And up in here, this would be the age of dinosaurs.
Though some geological change is slow, some is very fast. The heat inside the Earth causes changes in the crust that build mountain ranges and deep valleys. 1 billion years ago, movements in the Earth's crust made the basin that Lake Superior eventually filled. You can see Lake Superior's billion-year-old lava flows at Gooseberry Falls State Park. Glaciers also exposed rock in the Minnesota River Valley near Morton. It's part of the oldest rock formation on the North American continent, 3.6 billion years old. Minnesota has the longest exposed geological history in the United States. Can you name the natural forces that create geological changes? Well, the answers are water, wind, and ice, the great eroding forces, and the Earth's heat, the force that makes and transforms rock. Our last story took us to the highest point in the Twin Cities, Buck Hill. We saw how glaciers shape the landscape. The geology of a landscape, in concert with the climate in the region, will determine the kinds of natural resources there. In our next story, we'll return to Buck Hill and visit a quarry or mine just downhill from it. There, glaciers created one of Minnesota's most common mineral resources, sand and gravel. Do you know how we use it?
And there was maybe 1,000 feet of ice up there, 2,000, 3,000 feet.
Each glacial lobe scraped away at the surface rock that once covered Minnesota, revealing igneous bedrock near Lake Superior In the rest of the state, the crushed rock, sand, and boulders were rearranged and deposited as each glacial lobe moved and melted.
Okay, those are all rocks that come from northern Minnesota, and these came down on the glacier, and the glacier stopped near here, and then it melted, and all that water came pouring off the glacier and sorted out all these rocks here.
At its edges, the glacier dropped large piles of debris called moraines. Water from the melting glaciers carried layer after layer of sand and gravel in outwash streams. Today, you'll find these sand and gravel deposits in every Minnesota county, with active quarries in half of them.
We will dig that sand and gravel out, run it through a series of crushers, screens, wash screens, to get it to the specified sizes to meet the job. So, the aggregates behind me are used mainly for concrete products and for commercial roofing products.
At the Sheely Quarry in Lakeville, machines also sort the glacier's sand and gravel by size to put in asphalt for roads. The small rocks from a sand and gravel pit make good landscaping stone. Here they stop erosion from a downspout. And kids know that clean sand in sandboxes is lots of fun. But like so many other natural resources, the supply of clean, easy-to-mine sand and gravel is limited. And with landfills filling up, construction companies have started recycling.
What we're doing is taking in concrete rubble from buildings and waste concrete and reprocessing, recycling that into road product materials. That's one of our ways to save the resource for the future.
There's lots of sand and gravel in Minnesota, but clean, mineable deposits are less common. So recycling road building materials like concrete and asphalt conserve a non-renewable resource and at the same time reduces the pressure on our landfills. It's a good example of the way we're redesigning our whole society to make wiser use of natural resources. Can you name some of the things that we need sand and gravel for? We use it to make concrete. Sand and gravel is also used in asphalt for roads. There are materials used in landscaping, and for fun, sandboxes. The glaciers and glacial rivers that changed Minnesota's landscape left more than sand and gravel behind. They left an extensive water system on the surface and underground. At Mystery Cave in southeastern Minnesota, we can see those underground layers of sand and rock, aquifers, where most of us get our drinking water. When you walk through Mystery Cave with Warren Netherton, he'll show you rocks made by water, dripping for centuries.
It's a very difficult concept for people to grasp because we're talking about very minute amounts of solution over immense periods of time for this to occur. Water dripping in caves often will result in stalactites and stalagmites and flowstone, three of the commonest cave formations or speleothems found in caves.
The water in caves seeps through cracks in the limestone. It's part of an aquifer, a layer of sand or rock that holds water. On the surface, some aquifers are visible, especially where sand and gravel quarries have exposed the top of the aquifer, the water table. Most aquifers, however, are invisible, but they work in familiar ways.
When you take a flower pot, suppose I pour water in the top, then it's surface water when it's on the surface. But you know, if you put a lot of water on a plant, you start seeing it dripping out underneath. Well, that's the idea. That's what happens if water from the rain goes onto your garden. Well, where is it dripping out? Well, it's dripping out into the groundwater system.
That's called groundwater recharge. Some aquifers recharge in weeks. Others, deep down where the water is very clean, take hundreds of years. Under the Twin Cities, layers of sandstone make a layer cake of aquifers where most Twin Cityans get their drinking water.
It's very important to understand how water can get from one into a lower one and into a lower one. So we want to be sure that contaminants from near the surface, we want to be sure that those aren't going to flow down into the pure water down below.
In the limestone geology of southeastern Minnesota, where caves and sinkholes are numerous, surface water becomes groundwater quickly.
So there is simply no filtration. What you get on the surface is what you get underground, and that's the stuff that people drink.
Every year, Minnesotans dump 2 million gallons of used motor oil on the ground. That's illegal. And in some places, like the southeastern part of the state, it can pollute drinking water very quickly. So where do we Minnesotans get our drinking water? Most of us, about 75%, drink well water from aquifers. The rest of us, 25%, drink from surface water. We've now seen how geology determines the varied mineral resources of Minnesota, deposits of sand and gravel, surface and groundwater. Our next story looks at another valuable natural resource, soil. In south central and southeastern Minnesota, most soils are sandy and silty, but they need special care if they're farmed. Scientists are worried that industrial farming practices are polluting the groundwater under these soils. Minnesota has some of the best farmland in the world, but good soil for farming depends on what geologists call parent material. In Minnesota, that's deposits from the two most recent glaciers, the Des Moines and the Superior.
So the ice slope came down like this, spread out into this region, and deposited red sands and, well, mostly sand. It's a sand-rich material that was generated from the rocks that it passed over further north.
The last glacier entered from the northwest, carrying clay-rich shales and limestones. The state soil, the Lester soil, developed over these deposits.
And a part of the Des Moines lobe extended into the Twin Cities region, and as it melted back, a lake, a shallow lake formed in this area, and this is the Anoka Sandplain region.
Almost anywhere you go in Anoka County, you'll see the sand. Here, the glacial outwash streams deposited their sand in a wide fan. When the streams ran dry, the winds built dunes. The sand plain covers hundreds of square miles.
It averages about 50 feet of sand, very fine sand, and that's unusual. Here's a sample from 9 to 13 feet down of the Anoka Sandplain sand. It's gray here. If you are closer to the surface, it will look more yellow.
Rock particles even smaller than sand blew across the glacial landscape too. Called loess or rock flour, it was deposited over thousands of square miles from southeastern Minnesota to Indiana. Here in Goodhue County, scientists are studying the soil formed from loess to find out how fast fertilizers are traveling through it. In the Anoka Sandplain, fertilizers, pesticides, and herbicides sink into the groundwater quickly. So farmers and scientists with the Soil Conservation Service are building weather stations to measure rainfall. Then farmers will only pump the water crops need and slow the migration of chemicals through the sand into our drinking water. Irrigation speeds up pollution of groundwater by drawing farm chemicals down through the soil into the aquifer. Over 15% of the private wells in the Anoka Sandplain have levels of fertilizer nitrogen above state drinking water standards. And in southeastern Minnesota, more than 1/3 of the wells are polluted. Can you name some of the pollutants entering Minnesota's groundwater from farms and yards? The answers are fertilizers, especially lawn fertilizers with too much phosphorus, and pesticides and herbicides used on farms and yards. The human impact on the environment is evident everywhere, especially as more and more people use the Earth's mineral resources, particularly petroleum. Humans are now the biggest geological force on the planet. In Minnesota, the most striking evidence of human geology is the string of huge open pits left by mining companies on the Iron Range. Our next story looks at iron ore, our region's largest mining industry. Minnesotans produce almost 3/4 of the nation's iron ore for steel, but mining is changing. Today, new mines in the U.S. must take the environment into account as never before. Near the shores of Lake Superior lie the largest iron ore deposits on Earth. These huge veins of rock, known today as the Iron Range, began as layers of mud at the bottom of the huge, quiet inland seas that covered North America hundreds of millions of years ago.
And this is what was mined in the early days of the 20th century, and the holes that you see on the Mesabi Range today are what's left of those very large iron ore deposits. Very rich, easy to mine.
For decades, Minnesotans have produced more iron ore than anyone else in the world. Today, the richest ores are gone, but extensive reserves of taconite, a lower grade ore, remain.
In Minnesota today, that production is from the Mesabi Range, which is the giant iron ore deposit of the world. The Mesabi Range extends for 120 miles from near Babbitt westward across northern Minnesota to the town of Grand Rapids.
Mining has usually been a dirty business. Smelters and refining plants create air and water pollution. At the Dunka Hill mine, acidic precipitation dissolved toxic metals from a large pile of rock. This liquid, called a leachate, was seeping into nearby Birch Lake. To stop it, the mining company put a liner under the rock pile to catch the water. When mines close, they usually leave a legacy of pollution and human troubles.
Everywhere in the past, the idea was to get in, mine, and get out. Today, you can't do that any longer. A new mine were to start, the people who are going to operate that mine must plan from the day one how they are going to close that operation down. How are they going to restore the environment as best they can.
5 sticks of dynamite in there.
Minnesota's first iron ore mine, the Sudan mine, closed in 1962. Today, it's a state park, one way people can reclaim the resource.
We can't say mining is dirty, we can't have it, because we need to have it one way or another in our society. Our challenge is to make this process as clean and as environmentally benign as we possibly can.
Countries with informed citizens and progressive environmental laws are reducing the pollution caused by mining. The U.S. Bureau of Mines has even used cattails to clean up heavy metals like copper and nickel in polluted runoff from mines. What are some of the problems that mining creates for the environment? Well, the answers are air pollution, especially from smelting the mined ore, reclamation, restoring the landscape or finding a new use for the mine, and finally, a good vocabulary word, leachates, dissolved minerals from mining that leak into our lakes and aquifers. Mineral resources provide our society's energy, from fossil fuels like coal and oil to nuclear fuels like uranium, but we pass the costs of using them on to the environment. There's another geological resource, though, with much lower environmental costs that can replace them, and Buffalo Ridge in southwestern Minnesota has lots of it.
The human race is beginning to have a major impact on the surface of the earth. We are affecting the composition of the atmosphere, the composition of the water, the composition of the land, the shape of the land. It wasn't until there got to be 5 billion of us and we adopted a modern lifestyle that involves a lot of energy that we began to have that impact.
Geological forces took hundreds of millions of years to create fossil fuels, coal, natural gas, and oil. At current rates, humans will take just a couple of hundred years to burn them up, creating waste products that make acid rain and global warming.
We as a society are facing some really, really tough choices.
One possible path, more nuclear power, has waste products too. Used fuel rods from the nuclear reactor's core are highly radioactive. The U.S. government says 10,000 years is the time required for a fuel rod to reach a safe level.
What that means is that we have to bury it somewhere. That's not a necessary requirement. All we have to do is to keep this stuff from hurting someone.
In the meantime, a high plateau of bedrock in the southwest corner of Minnesota offers a way out of our fossil fuel and nuclear fuel dilemmas.
This is one of the highest areas in Minnesota, and it is the windiest area. It made it an ideal spot to put the wind turbines up here because the wind resource is so great. Kind of like having a 400-foot tower at this location, and the winds that come across North Dakota and South Dakota clip the top of this ridge.
The Minnesota Department of Public Service estimates that wind turbines on the Buffalo Ridge could supply 83% of the electricity our state consumes. And building a wind farm costs about the same per kilowatt as building a coal-fired power plant. Of course, winds don't blow all the time, so good wind power planning means having sites in many regions and then sharing power, as utilities do now, among regions. The worksheet assignment is to fill in the blanks. Since it takes blank 10,000 years for some blank nuclear waste to decay to safer levels, blank storage is nuclear power's biggest problem. So the worksheet answers are 10,000, nuclear, and storage. So far, we've seen how mining is changing to take better care of the environment. Next, we meet a man who buries the things we mine. He runs a landfill, but this is no ordinary landfill. The garbage business just isn't what it used to be.
You used to dig a hole and throw your waste in it, and a lot of times there wasn't anybody around to take care of it. I can remember the first dump that I went to as a kid, and that wasn't that long ago, where we just backed up to the swamp and threw our refrigerator and our glass and our cans in the swamp.
Today, Chris and his wife take care of 18 million cubic yards of landfill space set in a sand and gravel moraine north of the Twin Cities. They mine the sand and gravel, but before they fill the hole with garbage, they get it ready.
In 1986, we installed a plastic liner, and the liner acts like a big plastic bag that encapsulates the waste and collects the leachate, which is the water that comes out of the garbage, to a central point where we can pull it out and treat it.
It's one of a handful of landfills in Minnesota with an elaborate system of liners, leachate collection tanks, and backups for everything.
And of all the states in the Union, Minnesota has one of the larger groundwater resources. And we really need to protect that and be stewards of our resources here in Minnesota.
But very few landfills do have liners. Many are in old sand and gravel pits where the water table is just a few feet below. So precipitation leaks through the garbage, dissolves toxins and heavy metals, and before long pollutes the groundwater. Each of us produces about 4 pounds of garbage every day.
The best way to avoid disposing of materials in a landfill or a waste energy plant and desecrating the environment is to not generate the waste at all. Around World War II, we were a much less wasteful society, and everything had a price attached to it, so you didn't waste anything. And that's where we have to end up getting to again.
The Elk River landfill is a good example of how we can rethink our priorities and rebuild society within nature's limits. That's a sustainable future where non-renewable resources don't become garbage. Do you know the rules, the 4 R's of a sustainable society? They are reduce, reuse, recycle, and finally, redesign, using nature as the model. With the final installment of our Go for Rock series, we look at the common battery, a product of many different mining operations. The metals and compounds that make it work, however, are toxic. So many communities, and now 6 states, including Minnesota, have battery recycling programs. As you watch, notice the things made from mined minerals that we can recycle.
Really press it in there. So we're going to make a very simple battery out of a lemon.
The students at Battle Creek Middle School are finding out how easy it is to make a battery.
So it is kind of a fun experiment to do. Now let's see if the guys got theirs to work.
The lesson has a serious purpose, helping young people understand that the batteries they buy for radios and toys are environmentally expensive. Mining and refining the materials that go into batteries create pollution, and throwing them away makes more pollution.
About an average household throws away about 50 every year, and if you just multiply that by as many households there are in the U.S., you can see that it turns into a huge solid waste disposal problem with throwaway batteries.
The problem is that the heavy metals like cadmium and mercury used in batteries are toxic. Small button batteries contain the most mercury, and because over half the solid waste in Minnesota is now burned, the toxic metals in discarded batteries are being spread throughout the environment and entering the food chain.
Mercury is probably the most troublesome metal in Minnesota. It appears that the level of mercury in fish and lakes is rising about 5% each year.
Fortunately, battery manufacturers are reducing or eliminating the mercury in their batteries. Some are making rechargeables you send back to the company when they quit taking a charge. And cities are starting recycling programs to keep batteries out of the waste stream.
So virtually all household batteries will be collected within the city of Minneapolis.
Many packaging products like aluminum and metal cans are made from materials that started as rocks. Recycling them saves energy and finite resources. And more, people are gathering used batteries for recycling. Check to see if the fire station or community center in your city is a drop-off site. Keeping household batteries out of our landfills and garbage burners is another step toward building a sustainable society. We'll all be hearing a lot more about battery recycling in coming years. Manufacturers are setting up pilot recycling projects to keep these household batteries out of our landfills and garbage burners is another step toward building a sustainable society. We'll all be hearing a lot more about battery recycling in coming years. Manufacturers are setting up pilot recycling projects to keep these environmentally expensive products out of the waste stream. Can you name some of the products made from Earth's materials that we can recycle? The answers are batteries, of course, glass, which is made from sand, metal cans made from iron ore and tin, and aluminum cans. Finally, a big thanks to the Minnesota Geological Survey for its help on this series. One last thought about geology and mining. If it can't be grown, it has to be mined. And mining without polluting challenges us to rethink the way we mine and what we mine. We have to design new mining practices and build technology that uses nature as the model. Thanks for joining us. I'm Mike Fairborn from Weather Center 4.